Hey guys, welcome to this workshop. My name is Lakshantha and I'm an application engineer at SEEED Studio. My main areas of focus are IoT, embedded systems and AI. I have worked in this industry for about 4 years now. I have also worked as a Udemy instructor in the past. If you want to connect with me, you can check my LinkedIn, Twitter and also check my works on GitHub. Today I will teach you how to build smart environmental and AI sensor networks using the Things network. So this workshop will be mainly based on the following 3 topics. First, we will display environmental and AI vision sensor data on the bioterminal LCD and then send the sensor data to the Things network console and visualize on Azure IoT Central dashboard. Finally, I will teach you how to train your own AI model and deploy on the Grove AI vision sensor for detection. So sit back, relax and let's get started. So what exciting hardware do we have today? Here I have the SenseCap K1100 kit, which is a sensor prototype kit powered by LoRa and AI technologies. This is the kit that we will be using for this workshop. Now let's dive into what we get with this kit. First of all, it comes with the bioterminal, which is the brains of this kit. Bioterminal is powered by an ATSAM D51 microcontroller and it is equipped with a 2.4-inch LCD while having a nice enclosure. Also, it has several built-in sensors such as a light sensor, sound sensor, accelerometer and a buzzer. It has built-in buttons that can be used to navigate around UI projects that uses the bioterminal LCD and also to trigger any function you want. Next, it comes with the Grove VioE5 module embedded with VioE5 LoRaWAN STM32 WLE5JC powered by ultra-low power ARM Cortex M4 MCU core and Vio XX126X, which is a wireless radio module supporting LoRa and LoRaWAN protocol on multiple frequency bands and FSK, BPSK, MSK LoRa modulations. This module enables ultra-long transmitting range via LoRa. Next is the Grove Vision AI module, which is powered by HiMax HX6537A processor with 400 MHz DSP while having ultra-low power consumption. So out of the box, it is pre-installed with an AI algorithm for people detection and you can load other customized models as well. It also has an onboard 6-axis accelerometer and a microphone. Being easily deployed and displayed within minutes, it is perfect for getting started with AI-powered camera projects. Next is the Grove SHT40 digital sensor, which is based on Sensirion's industry-proven humidity and temperature sensors. It can provide constant temperature and humidity accuracy over an extensive measurement range. It offers lower power consumption, which makes it highly suitable for low power and battery supported applications. Next is the Grove VOC and ECO2 gas sensor, which is an air quality detection sensor. This Grove module is based on SGP30 and provides TVOC, which is total volatile organic compounds, and CO2 EQ output. As a metal oxide gas sensor featuring multiple sensing elements on one chip, SGP30 provides more detailed information about the air quality. Finally is the Grove soil moisture sensor that can be used for detecting the moisture of soil or judge if there is water around the sensor. This sensor is very easy to use. You can simply insert it into the soil and read the data. Now that I have introduced all the sensor modules that comes with this kit, how are we going to connect them all to the bioterminal? Well, you can simply use the onboard Grove connectors on these sensor modules and connect them to the Grove connectors on the bioterminal via the included Grove cables, as you can see here. Also, the left Grove connector on the bioterminal is an I2C port which can be used as a digital port, whereas the right one is a configurable digital analog port, which can also be used for PWM outputs. In order to complete this workshop, you just need 3 things. So first, you need a SenseCap K1100 kit. Second, you need the Things network coverage. And third, you need a PC with an internet connection. If you are interested in checking out the LoRaWAN gateways supported by the Things network available at SEEED Studio, you can visit this URL and explore all the gateways available. Now, we will move on to the first section of our workshop, which will be about displaying environmental and AI vision sensor data on the bioterminal LCD. So here I have the bioterminal. So let's turn it on. So as you can see, I have connected a USB Type-C cable to this port to provide the power to the bioterminal. And then you just need to slide this switch down once, and the bioterminal will be on. So the firmware that comes with the bioterminal inside the K110 kit at the moment is pretty old. So what we need to do now at first is to upload the latest firmware to this bioterminal. So this is the GitHub repo that we use to develop the firmware for the bioterminal, which comes with the K1100 kit, and it's called SenseCraft. So if you want to learn more about this firmware, you can check the code and also the README file here. So I will not dive much into details here. So what we will do now is go to the releases page, this releases, and we need to grab the latest firmware from this releases page. So at the moment, this is the latest firmware, so version 0.2, but we will keep on adding new functions to this firmware in the future. So when you visit this page in a later point of time, you will see new firmware versions. So make sure to download the latest firmware available inside this page. So let's click this file to download it, the UF2 file. So now the file has finished downloading. Now, in order to upload this file to the bioterminal, we need to enter bootloader mode on the bioterminal. So to enter bootloader mode, we will first turn on the bioterminal as before. So turn it on once, and from this on position, press down this on button 2 times, and that should be pressed down fast. So 1, 2. So when you do that, you will see a new drive inside the file explorer on your PC, which will be named as Arduino. So open it and then copy this .uf2 file that we downloaded before into this drive. So copy this and paste it here. So once it's finished copying, as you can see, the drive is disappeared. So if the drive gets disappeared, that means the firmware is successfully uploaded to the bioterminal. After the new firmware is uploaded, the bioterminal will automatically boot from the new firmware. And now you can see this is the latest firmware that we have released. So now let's navigate around a little inside this firmware. So basically you can see this user interface is broken down into 3 parts. So first is the sense and process, then uplink. So inside the sense page, you can see that it displays all the sensor data from the built-in sensors from the bioterminal. So first is the light sensor, so that is the light sensor value, and then is the sound sensor. So in this 5-way joystick, you can press to the right to go to the next sensor. So this is the sound sensor, and this is the IMU. So that's a 3-axis IMU built inside the bioterminal. And if you go one step to the right, you can see that there's a small message saying that plug in a Grove sensor. So this means you can directly plug Grove sensors into this Vio terminal and display the sensor data over here. So let's do that now. So here I have the Grove SHT40, which is the temperature and humidity sensor. So it is already connected to this Grove connector, and now let's connect this end to this port of the Vio terminal. Just connect it. So you can see, as soon as you connect it to the Vio terminal, you can see the temperature and humidity sensing information displayed on over here. So similarly, let's try out some other sensors as well. So this is another sensor which comes with the K1100 kit. So that's the VOC and ECO2 gas sensor based on the SGP30 module. So let's connect it as well. Connect the Grove connector, and then over here it's connected to this Grove port, and as you can see, the data is instantly shown on the LCD. The data, the sensor data coming in from this gas sensor. And then we will move on to another sensor. So this is the soil moisture sensor which comes with the kit. So let's connect it as well with the Grove connector to this same port. Just connect it, and yeah, you will see the data instantly. So it's showing like 10 because it's not connected to a soil at the moment. Next we will move on to an exciting sensor which comes with this kit, which is this Grove Vision AI module. So let's connect this just like before to the Grove connector, and then connect to the Vio terminal. So mainly when using this particular module, we use the process page. So this second button you need to press down to enter the process page, and once you enter the process page, you can see the Vision AI real-time analysis. So click on this button to enter it. So here you can see like a log, a sensor log. So basically this particular module, which is the Grove Vision AI module, comes with a people face detection model out of the box. So it is able to detect people's faces. So let's try it out. So now if you point the camera of the Grove AI Vision module to people, it will detect the people and display the detection information on this particular log. But here I will show you how to preview that detection as well, so that we can really see how the people's faces are being detected in the video stream. So for that, we need to connect the Grove AI Vision module into a PC by using a USB Type-C cable. So I will just connect it like this, and then once you connect it, you will see this pop-up window on your computer saying that Grove AI detected, go to files.seedstudio.com to connect. So just click on this and it will go to this page. So if you don't see that pop-up window, you can manually type this URL to enter this web page. So once you are inside this web page, just click this button, connect, and it will show two devices for us. So this is the Vio terminal itself, and this is the Grove AI Vision module. So this is what we need to select, Grove AI paired, and then click connect. So now it's connected to the camera stream. As you can see, my face is being detected in this video stream. So this 0 means the detection of my face itself, and 84 means the confidence score. So the confidence score is on a scale between 0 and 100. So if we look at the Vio terminal now, we can see that the detection information is being displayed on the LCD. So that is all about displaying environmental and AI vision sensor data on the Vio terminal LCD. I also want to mention that in this GitHub repo, if you come down in the README, you can see under functions list, these are the functions that are already implemented in the current firmware version. So from the function number 9, so all these functions will be later added to this firmware. So stay tuned with us and regularly check this GitHub repo to see whether a new release has released over here. So if a new release is released, you just have to upload the .uf2 file as we did before in this workshop to get the latest firmware up and running on the Vio terminal. Now that we are able to display all the sensor data on the Vio terminal LCD, let's move on to sending this sensor data to the Things Network console and visualize on Microsoft Azure IoT Central dashboard. Before moving on, I will briefly explain how the network architecture is going to look like. So basically, we will connect this Grove Vio E5 and the Grove temperature and humidity sensor to the Vio terminal, and first display the sensor data on the LCD just like we did before. After that, we will send this sensor data to the Things Network using a LoRaWAN gateway that is available nearby. So you need to make sure that you are within range of a LoRaWAN gateway that is connected with the Things Network. So after sending the data to the Things Network, we will integrate Azure IoT Central with the Things Network so that we can visualize all the sensor data on a beautiful dashboard like this. So now let's continue to build this. First, we need to register the Vio terminal on the Things Network as an end device. To do that, open a web browser and visit this URL cloud.thethings.network. So visit this, and then you need to select a cluster from these three. So I will select Europe from here. And then you need to log in to the Things stack with the Things Network ID. So for this, I have already created an account. So I will log in from here. So if you don't have an account, you can click this to register. So this is my account. I'm logging in. So if you go to gateways, we can see that I have already set up a gateway on the Things Network, and I'm already in the coverage of this gateway. So now what we have to do is we need to go to applications and create a new application. So you need to click this add application button and then give an application ID. So I will name it as SenseCap K1100. So it says it can only contain lowercase letters, numbers and dashes. Okay. So I will change this to lowercase SenseCap K1100. That's good. Then you can leave this blank, or you can fill this if you want. So I will leave them blank and then create application. So now we have finished creating the application. Now what we need to do is we need to add an end device. So click this button, add end device, and then make sure you are under this from the LoRaWAN device repository. So we have already added the Vio E5 support officially to this LoRaWAN device repository. So you can simply type SenseCap, and then in the model select this Vio E5 STM32 WL-E5JC module, this one, and then hardware version keep it as 1, firmware version 1, and under profile select the region you are in. So I will select US 902.928 because the gateway that I have set up is in this region. So you always make sure that the region of the end device and the region of the gateway is the same. Otherwise, the end device will not connect with the gateway. So we have selected this device. So let's go down, and we need to enter the registration data. So under the frequency plan, select the one which says used by TTN. So that is the recommended option. So click this, and now we need the app EUI, dev EUI, and the app key. So if you check the back of the Grove YOE5 module, you will see a sticker like this pasted with some information on it. Basically, it has the information such as the dev EUI, and here it's just the code, it's not the app key, and finally it has the serial number. So the dev EUI, app EUI, and the app key are all flashed into this Grove YOE5 from factory out of the box. So what we need to do is, we need to use an HTTP API to obtain the app EUI and the app key, because we already have this dev EUI. So to do that, you need to follow this URL format, and for these two spaces, replace with the EUI and the key. As you can see from here, the EUI and the key. So when you type the URL like this, replacing the EUI and the key, you will see this page where you can find the dev EUI, app EUI, and the app key. So first, copy the dev EUI, paste into here, dev EUI. After that, copy the app EUI, paste it here, and finally, copy the app key and paste it here. So after you do that, just click on this register end device. So now our end device has been registered with the Things network. Now we will move on to sending the sensor data to the Things network. So this is the Grove YOE5. So we will connect this Grove cable to the Grove connector first, and then connect this module to the left Grove port of the YO terminal. So connect it like this. And now it's time to connect this Grove temperature and humidity sensor to the YO terminal. So just connect it to the Grove port on the right side. Turn it on. And now you can see that the connected temperature and humidity sense information is coming in to the display. And now we will click this uplink button. So that is the 1, 2, 3, the third button to enter the uplink page. And here you need to select LoRa. So press down this button while LoRa is selected. And here you can select the frequency band. So I'm using US 915. So just click on it. So I will click on it. And on this page, click again. So wait a few seconds. So now it's establishing the connection. As you can see, these LEDs are blinking on the Grove E5 module. So LoRaWAN init success, you can see. So if you see this LoRa next to network, that means it's connected. So you can also see the signal strength now. And now one data packet is already sent. Now 2 packets are sent. So now let's quickly jump back to the Things Network console. So in the Things Network console, if you go to live data, so we can see it has received some data. So from here, so this is where we created the device, accept join request, successful processed. So now the device is connected, and you can see this is the payload sent by the Grove E5 to the Things network. So by default, this firmware sends the sensor data in 5-minute intervals. So the next data package will be sent after 5 minutes. So actually this payload is not very meaningful to us. It's just a bunch of letters and numbers. So what we need to do is we need to convert this payload into a format that we can understand. So for that we need to add a decoder function. So visit the SenseCraft GitHub repo again and go to tools, and there you will find K1100 decoder.js. So open it. So here you just need to copy these codes and then come back to the Things Network console. Under payload formatters, so you can see there's uplink and downlink. So select uplink, and then under the formatter type, select a custom JavaScript formatter, delete everything inside, and then paste the copied code. So after this, simply click this to save the changes. And now let's go back to live data and wait for the next data packet. So as you can see, now the payload, we can understand the information because of the decoder script that we loaded. So here you can see the IMU X, Y, Z values, the light sensor value, and the mic, the sound sensor values. Also the temperature and humidity sensor value from the connected Grove temperature and humidity sensor. So if you guys can also see the sensor information like this, that means you have successfully followed throughout this workshop with me until this point. Now we will integrate Microsoft Azure IoT Central with the Things Network so that we can display the sensor information on Microsoft Azure IoT Central dashboard. Visit apps.azure-iotcentral.com and then click here to sign into your Microsoft account. So I will sign into my account. So after signing in, go to apps and then click here to create a new application. So custom app, create app, click on this, and here type a name for the application. So here we will type K1100, and then for me I will choose the pricing plan as standard 0. But for you guys, when you create an IoT Central account for the first time, you will have a 7-day free trial. So there will be another option here saying that there is a 7-day free trial. So you can choose that option. After that, click create. So now it's provisioning your application. So now we are inside our application. Click here to expand the side navigation bar. So if you go down under security, select permissions and then click on device connection groups, SaaS IoT devices, and now go back to the Things Network console. Under the SenseCap K1100 application that we created before, there's this section called integrations, and under that you can find Azure IoT. So click on it, and under Azure IoT Central, expand this. So there will be 2 columns to fill here. One is device provisioning service scope ID and the service access key. So go back to the Azure IoT Central. So we need to copy this ID scope. So simply click this to copy it and then paste it here. And the service access key will be this, the primary key. So just copy it by clicking here and then paste it inside this column. And finally, click Enable Azure IoT Central Integration. So now we have created the integration. So let's go back to the Azure IoT Central, go to devices. Let's wait a few seconds. So now it says updates available. So refresh. So click on this. And now we can see that under devices, this device is already created for us. So click on this. And we can see the raw data coming in to Azure IoT Central. So let's have a look at it. So we can see that the temperature, humidity is coming in. And let's look at some other data. So you can see the IMU XYZ light and the mic, the data is coming in. So what we need to do now is we need to click on this manage template and auto create template. So here click this create template. So now it has created this template. So what we need to do is we need to go to this overview and create a dashboard. So I'll make a simple dashboard. Let's take a line chart from here. Click this edit, and under telemetry, click on this capability, and then we'll add a capability. So let's add light. So that's a light sensor. And for the title, let's change it as light and click update. After that, let's create another line chart. So that will be for the mic, yes, mic, and then another one for the IMU. So line chart for this one should be IMU, and then here let's add 3 capabilities. So one will be IMU X, IMU Y, and IMU Z. Update. So what else? We can add the temperature and humidity sense information. So temp and humi. So let's add it as well. See whether it's there. Temp is there. So temp and the humidity as well. Humi. Yes. Update it. So we'll make it smaller. So we will add a few more things. Let's add this last known value for the light. Let's make it smaller, 1 by 1. Yes. And then let's add another one for the IMU. So IMU, let's add 3 capabilities like before. X, Y, and Z. Yes. Update. Make it smaller. Arrange it. Let's add it for the mic also. The same thing. Sub the capability as mic. Update. Change the size. And finally, let's add the temperature and humidity sensor also. So temp and humi. So add the capability, temp, humidity, right, update. So we have created the dashboard. Now click save. So after saving, what we need to do is go back. So this is good. So click this button to publish all the changes. So publish and then click publish again. So now it's published already. So go to devices then this device, and if you go to overview, you can see the dashboard that we just created. So we can see that the line charts are properly created after running this for a couple of minutes. So if you are also able to view the dashboard like this, congratulations to everyone. You have successfully followed along with me until now. If you want to learn more about the sensor nodes, the gateways and the edge devices offered by SEEED Studio, you can visit this URL and learn more about them. Now we will move on to the next section of our workshop, which will be about training your own AI model and deploying it on the Grove AI Vision sensor for detection. So when comparing this section with the previous sections in this workshop, I would say that it's going to be a little bit hard, but if you carefully follow along with me, you will be able to successfully complete this section. So first of all, I will briefly explain the software platforms and the technologies that we will be using in this section. So the very first step of an object detection project is to obtain data for training. So you can either download datasets available publicly or create your own dataset. So usually public datasets are used for education and research purposes. However, if you want to build specific object detection projects where the public datasets do not have the objects that you want to detect, you might want to build your own dataset. So if you want to build your own dataset, you want to annotate all the images in the dataset. So for that annotating task, we will use the RoboFlow platform. So after preparing the dataset, we have to train an object detection model. So to train an object detection model, we will use YOLO v5. And finally, to inference. So inference means detecting objects in an image. So to do this inferencing, we will use TensorFlow Lite on the Grove AI Vision module. Now let's dive a little bit more into these technologies. So RoboFlow is an online annotation tool. So by using RoboFlow, you can easily annotate all your images, add further processing to these images. So if we look at the RoboFlow annotating interface, so this is what we can see. So as you can see, this particular image has two different classes. So these are the two classes. So the first class is a pink flower and the second class is leaf. So for each and every class, those objects are annotated, which means these kind of bounding boxes are drawn for each object to detect. So after we prepare the dataset with all the annotated objects, we can easily detect these objects from the Grove AI Vision module. You can export these labeled datasets into different formats such as YOLO v5, PyTorch, Pascal VOC and more. But in this workshop, we will be using YOLO v5 PyTorch export format. So what's interesting about RoboFlow is that it also has public datasets which are readily available to users. So as I explained before, you can either use public datasets or create your own datasets, right? So public datasets will be the fastest way for you to experiment with object detection applications. So talking about YOLO v5, so YOLO is an abbreviation for the term you only look once. So it is an algorithm that detects and recognizes various objects in an image in real time. So Ultralytics YOLO v5 is the version of YOLO based on the PyTorch framework. So in this workshop, we will use YOLO v5 to generate an object detection model, and we will do that later. So finally, for the inference part, so the TensorFlow Lite will be used as I mentioned. So TensorFlow Lite is an open source, product-ready, cross-platform deep learning framework that is optimized for speed or storage, which means it is mainly built to run on edge devices like mobile phones, like Android, iOS, or Linux based embedded devices like the Raspberry Pi, other microcontrollers, and the Grove AI Vision module that we will use in this workshop. So this will be the basic workflow that we will be using during this section. So first of all, we will use a publicly available dataset which is already annotated, because this is the fastest way to experiment with object detection. After that, we will train an object detection model using YOLO v5 on Google Colab platform. Since we are using Google Colab, which is based on the cloud, to do the training, you don't need to have a computer with very high performance with a very big GPU, because all the training will be done on this cloud. So you just need a web browser on the computer. Next, we will export this YOLO v5 model to a TensorFlow Lite model. And then after exporting this model, we will deploy it to the Grove Vision AI module. Finally, we will perform inference on the Grove Vision AI module. So if anyone is interested in building their own dataset to perform the object detection, so I will also explain that as well, where you collect your own dataset using the Grove Vision AI module camera and then annotate all the images and go through this training process and all the deployment process. Now let's go ahead and find a publicly available dataset which is already annotated. So you can simply search for open source datasets on Google and choose from a variety of datasets available online. However, here we will be using RoboFlow Universe. It is a recommended platform which provides a wide range of datasets, and it has 90,000 plus datasets with 66 plus million images available for building computer vision models. So here we will search for a dataset. So you can see there are a lot of datasets. So over here, let's type Apple to find the Apple detection dataset. So go down and let's use this Apple detection dataset. So if you want to easily find this dataset, you can also visit this URL directly. So mainly this dataset is mainly used to detect apples, right? So if you go to these images, we can see that they are already annotated. So we don't need to annotate it anymore. So go back to overview and then click download this dataset. So here it asks to log in or create an account in RoboFlow. So I will just sign in with Google here. Now after signing in, here for the format, you need to choose YOLO v5 PyTorch. So choose this and then click this show download code and then click continue. So this, just keep this on the background, this window, because we will use this piece of code snippet later in the training process. Now let's move on to training using YOLO v5 on Google Colab. So please type this URL on a web browser to open an already prepared Google Colab workspace to go through the steps mentioned in the workspace and run the code cells one by one. So let's do that now. So let's copy it here. And then this is the Google Colab workspace that we are going to use for the training process. So first of all, you need to log in with a Google account over here. So I'm already logged in. And then go to runtime, select change runtime type, and make sure under hardware accelerator, GPU is selected. So for me, it's already selected. So click save and then click here to connect. So now it's connected. So if we click this, we can see that the system RAM, GPU RAM, and the disk, the usage is shown. So now we are not utilizing any resources because we are not running any cell. So they are just sitting at idle. So close this. And now let's go through these code cells one by one. So we already did the first step, that is to change the runtime type to GPU. And then next we will need to clone this repo, install dependencies, and check PyTorch and GPU. So you just need to click this button, this play button, to execute all the codes inside this cell. So for this warning, just click run anyway, and it will start running the commands. So now it's finished. When you see this tick mark, that means all the commands inside the code cell are finished running. So next we will set up the environment. So click this. And next we will go back to RoboFlow. So you remember we got this window before in the RoboFlow. So go back to it and then just copy this, paste it inside this cell, and then click this to run it. So it's still running. Now it's downloading the data set. You can see it's downloading from RoboFlow. So this is actually, we are using the RoboFlow API here to grab the data set from RoboFlow. So now it's finished. And okay, so if we run this code cell, we can see that the data.yaml file, so this is automatically generated by RoboFlow, which is used for the training process. So as you can see, this is the name, the apples. So that is the object that is labeled inside the data set, and this means only one class. So next we will download a pre-trained model suitable for our training. So here we use a pre-trained model because if we want to perform a training process from scratch, we will need a lot of images in the data set, thousands of images. But by using pre-trained models, so basically this model file, so YOLO v5 n6 shower.pt, right? So this is the model file. This model file is already trained before for another data set. So that is mainly trained for the COCO dataset with 80 different object classes. So when we use this kind of pre-trained models to do a training, it will drastically improve the training performance. Like we don't need to use a lot of images for our training. So for example, in this dataset, we only have 699 images. So with only 699 images, we are able to perform an object detection training just because we are using a pre-trained model. So this kind of technique is called as transfer learning, where we use a model that is already trained before to train a new model with the new data set that you have to make the training process much faster and also to make it accurate. So let's run this code cell to get this pre-trained model. So it's already downloaded. So now it's time to start the training process. So before running this code cell, I will briefly explain some arguments that are used in this code cell. So IMG defines the input image size. So you can see Python 3 train.py is the file that is used for training, the script that is used for training, and the input image size we set as 192, because if we choose a higher image size, that will affect the inference performance on the Grove AI Vision sensor. So that's why we use a lower value for the image input size. However, choosing a higher input image size will improve the accuracy a little bit when compared with lower image sizes. But using 192 as the image size will not really compromise the object detection accuracy. So here we determine the batch size as 64, and then for this epochs, so we use 100, so it defines the number of training cycles. And for the data, the YAML file path, right? So this is the data.yaml file that is generated from RoboFlow before. So CFG is this to specify our model configuration. So we so this is already available in the repo that we cloned before, this this YOLO v5 Swift repo. That file is there already. So, and for the weights, we use the pre-trained model that we just downloaded before. And for the name, so name is the results name. So it will save all the trained models inside a new folder called YOLO v5 n6 results. So finally, we use this argument cache to cache images for faster training. So now it's time to hit this button to start our training process. So based on the number of images that we have and the input image size, it will not take a lot of time for the training process to complete. So let's see. So it's starting all the processes. So this is the epochs. So now it's trying to run through the first cycle. So let's see how long it will take for the first cycle. It says around 15 seconds. Yeah. So in total we have around 100 cycles, right? So I will come back to this after the 100 cycles are finished. So now the training has been finished, and it took around 11 minutes to complete this training. So you can see that the results are saved under this directory. So here we obtain this file, the model file called best.pt. So that's in PyTorch format. So now we have to convert this PyTorch model into a TensorFlow Lite model. So this code cell is responsible for that. So click on it. So it will take some time for this process to finish, a couple of minutes or seconds maybe. So it's finished, you can see. And now what we will do is we will convert this TensorFlow Lite model file to a UF2 file. So UF2 is a file format developed by Microsoft, and SEEED uses this format to convert the TF Lite model to a UF2, mainly to deploy on sensors such as the Grove AI Vision module. So currently SEEED's devices, and including the Grove AI Vision module, support up to 4 models, and each model is less than 1 megabytes. So So you can upload 4 models to the Grove AI Vision at the same time, but you can only choose one model when doing the inference. So here you can see that you can specify the model to be placed in the corresponding index with -t. So for example, -t1 means placing the model file at the index 1, and -t2 means placing at index 2. So in this particular training process, and in this section of the workshop, we are only going to deploy a single model file. So we will just use this index 1 to place the model file, and it is already defined in this code cell. So just run it, and now to download this UF2 file, you just have to simply click this code cell, and it will start downloading your file. Here you can see here it's already downloaded as the model1.uf2. So this is the file that we will load into the Grove Vision AI module to perform the inference. Now let's move on to deploying the TensorFlow Lite model that we downloaded before to the Grove Vision AI module. So first of all, you need to connect the Grove Vision AI module into your PC via the included USB Type-C cable in the kit. Next, you need to double-click the boot button on the Grove Vision AI module to enter mass storage mode. So after you do this, you will see a new storage drive shown on your file explorer as Grove AI. Open this drive, copy and paste the model1.uf2 file that we downloaded before into this Grove AI mass storage drive. And if you see this, so it's copying, and if it disappears like this, it means it has successfully loaded the UF2 file into the Grove AI Vision module. Now let's perform inference on the Grove Vision AI module with the loaded Apple detection model. So as we did before, make sure the Grove Vision AI module is connected to the right Grove port on the VIO terminal, and then connect the module to the computer using a USB Type-C cable. After that, once you see this pop-up message, click on it, or else visit this URL to open this web page. And then you need to select the Grove AI module from here, connect to it, and finally we can see that the apples are being detected by the system. If you want to collect your own dataset using the Grove Vision AI module and then annotate all the images, you can visit this wiki page and learn more about it. If you go down, there's this section which explains how you can use the Grove Vision AI module to collect images so that you can make a data set and then use RoboFlow to annotate all the images in the data set. That's it for this workshop. Thank you all for listening, and I hope you all were able to follow along with me and build smarter sensor networks with the Things network and SenseCap K1100 kit. So if you want to learn more about this kit, you can visit this URL to dive deep into the SEEED wiki pages. Enjoy the rest of the workshops and be creative.